attempting AP Chemistry year 2025 structured questions, which are free response questions. So answer the following questions about magnesium. An incomplete mass spectrum of magnesium is shown in the diagram. The percentage abundance of magnesium 24 isotope is 79%. The percent abundance of the other two natural isotopes of magnesium 25 and 26 are approximately equal. That means if total abundance is 100, if you are subtracting for isotope 24, that is 79, we are remained with 21%. And if 25 and 26 they have the equal abundance, then 21 by 2, that comes out to be 10.5. So it comes out to be, we have to draw the graph for it. It is going to be like this. At 10.5, they both are at 10.5, like this. So the next question is saying, describe the difference in atomic structure that contains for the difference in between magnesium 24 and magnesium 26. So both is having the atomic number 12 and is 25, and the other magnesium is 12, 26. If we count their number of neutrons, which are going to be atomic mass 25 minus 12, that comes out to be 13. And if we count the number of neutrons here, that is 26 minus 12, that comes out to be 14. So what we can say here, that magnesium 26 has one more neutron than magnesium 25. So the next question, a student prepares a 1.85 times 10 to the power minus 3 molar solution of magnesium nitrate in beaker 1 and 2.80 times 10 to the power minus 5 molar solution of NaOH in beaker 2. The particle diagram shown represents a magnesium ion in beaker 1. A sodium plus ion in beaker 2 has weaker attraction to water than magnesium plus 2 does. Explain the phenomena using Coulomb's law and each of the following. Force, like Coulomb's force of attraction is equal to K Q1 Q2 divided by R square. That means force is directly proportional to the product of charges and inversely proportional to the distance between the ions. So one thing, if we compare magnesium plus 2 and sodium ion, like magnesium plus 2 is having the smaller ionic radius. Why it has smaller ionic radius? Because it has plus 2 charge. Okay, like for example, the protons here are going to be 12 protons and electron are going to be, as it has lost 2 electrons, so it is going to be 10. And in sodium we are having proton 11 and we have electrons which are 10. So here you can see like more protons are in magnesium which are pulling 10 electrons as compared, so it is going to have stronger force of attraction. Like magnesium plus 2 is going to have stronger force of attraction from nucleus towards the valence electrons or the all electrons, while sodium, which is having 11 protons, they are pulling the same amount of electrons, so their force of attraction is less. So it is going to have more force of attraction because of greater charge and smaller size. More force of attraction because of greater charge and smaller ionic radius. So we know, according to Coulomb force of attraction, if you have greater charge, then the force of attraction would be stronger. And if you have smaller ionic radius, which magnesium has, then you also are going to have stronger force of attraction. So how I'm going to write this explanation? So this is going to be the right explanation for them. Now, moving towards the next question, C part, calculate the pH of the solution in beaker 2. We are only given with the concentration of NaOH, and we know when NaOH is dissolved in water, it completely ionizes and forms sodium ion and hydroxide ion. So if we have 2.8 times 10 to the power minus 4 as its concentration, then OH ion concentration will also be the same. And we know we have a formula POH is equal to negative log of hydroxide ion concentration. Negative log of hydroxide ion concentration is 2.8 times 10 to the power minus 4, and it comes out to be how much? It comes out to be 3.553. This is POH. Then we know pH plus POH is equal to 14. If we want to find out the value of pH, plus 3.553 is equal to 14, and pH comes out to be 10.447. That is going to be the pH. So for the next question, a student combines 35 milliliter of 1.85 times 10 to the power minus 3 molar magnesium nitrate with 50 ml of 2.80 times 10 to the power minus 4 molar NaOH as shown in the diagram. Calculate magnesium ion concentration after the two solutions are combined but before any reaction take place. Assume that volumes are additive. This statement is very important for us. So they are saying after the two solutions are combined but before any reaction take place. So we have to find out the concentration of magnesium ion. This is magnesium nitrate, and we are going to keep this one as M1, this one as volume V1, and after combining both of the solution, this is volume V1 and this is V2, and after combining them, the V2 volume, that would become 35 plus 50, that is 85 ml. And if we are going to convert it into but we don't need to convert it into milliliter into liter, so we can keep it equal to milliliter. Now we can use this formula M1V1 is equal to M2V2. M2, we need to find the concentration of magnesium nitrate, which will become M1V1 over V2. M1 is how much there? M1 is 1.85 times 10 to the power minus 3, and V1 is going to be 35. At bottom is going to be V2, which is 85, and the answer comes out to be 7.62 times 10 to the power minus 4 molar. So for the next question, the dissolution of magnesium hydroxide is represented by the following equation. Write the expression for the solubility product constant Ksp. Ksp is a solubility product which will show us in the equation. We are going to choose the product only. Product is magnesium Mg plus 2, and we have hydroxide, and we have 2 mole of hydroxide, so I'm going to put 2 at the top. Now they are saying after the two solutions are combined in beaker 3 as described in part D, but before any reaction that take place, the concentration of hydroxide ion is 1.65 times 10 to the power minus 4. Use your answer to part D. Calculate the value of reaction quotient Q. Q is going to be equal to magnesium concentration we have found before, that is 7.62 times 10 to the power minus 4. 7.62 times 10 to the power minus 4. and then hydroxide ion concentration, which is 1.65 times 10 to the power minus 4 whole square, and the value of Q that comes out to be 2.07 times 10 to the power minus 11. Use the reaction quotient Q, predict whether a precipitate should form as the mixture in beaker 3 approaches equilibrium. So for that purpose, we need to compare the value of Q and KSP. And if you see that, then Q is greater than KSP. If Q is greater than KSP, that means the reaction, or you can say the equilibrium move towards left hand side. The equilibrium shift towards left hand side, and more precipitate will form. More precipitate will form. In the next part, they are saying in a separate experiment, the student adds HNO3 to decrease the pH of a saturated solution. So they are saying, does the amount of undissolved magnesium hydroxide increase, decrease, or remains the same? So we know we have a equation MgOH2, and there is a equilibrium that has been established as Mg plus 2 minus in aqueous form. So when you are adding hydrogen ion into it, so what hydrogen ion will do? Hydrogen ion is going to react with hydroxide ion and form water, and the equilibrium will shift towards right hand side and the solubility will decrease. Magnesium hydroxide in solid state would dissolve more because hydrogen ion reacts with hydroxide ion and magnesium, and the quantity of magnesium hydroxide will decrease. And in order to balance it, according to Le Chatterjee principle, the equilibrium will shift towards right hand side to have more quantity of hydroxide ion. So how I'm going to write the detail? So this is the right explanation, that the quantity of magnesium hydroxide will will decrease. And why it decrease? Because hydrogen ion from HNO3 will react with hydroxide ion, and the concentration of hydroxide ion will decrease, and the equilibrium will move towards right hand side. And because of that, magnesium hydroxide will dissolve more. Now for the next question, a student combusts a sample of azobic acid to determine its chemical composition. The only product of the reaction are 0.24 mole of carbon dioxide and 2.883 gram of water. So first they are saying calculate the number of moles of water produced. So if we want to find out the moles of water, we have a formula: mass over molar mass. Mass is how much there? That is 2.883, and molar mass is going to be 18 there, and the answer that comes out to be is 0.16 mole of water. Then they are saying the ratio of carbon to oxygen is 1:1 in azobic acid. Based on this information and your answer in part A, determine the empirical formula of azobic acid. So we have to find out the empirical formula of azobic acid. So now we have to find out the empirical formula. For that, we need to have carbon, hydrogen, and oxygen moles. They are saying the mole ratio of carbon to oxygen is 1:1. So carbon dioxide basically contains 0.24, like contains 1 mole of carbon. First of all, 1 mole of carbon. So if it contains 1 mole of carbon, then 0.24 mole of carbon dioxide contains 0.24 mole of carbon as well, because we have 1:1 there. And as they were saying that carbon to oxygen ratio is 1:1, so if carbon to oxygen ratio is 1 to 1, and if this is 0.24, then this is also going to be 0.24. Then let's find out the hydrogen from water. So we know one thing here, that we have 0.16 mole of water, and 1 mole of water that contains 2 mole of hydrogen. So it comes out to be 0.32 mole of hydrogen. So now we have mole of hydrogen, we have mole of carbon, and we have mole of oxygen as well. So let's put here 0.32, and that's going to be 0.24, and that is also 0.24. Dividing with the least value, this is 0.24, this is also 0.24, and that is also 0.24. And the answer that comes out to be is 1:1.33 ratio 1. And now we have 1.33, so we have to convert it into whole number. So for that purpose, I'm multiplying this with the value 3 to convert it into whole number. That becomes 3:9, 3:4. This is going to be 4. 1.33 times 3 is 4, and that is going to be 3 as well. So it becomes C3H4O3. Now for the next part, they are saying azopic acid act as a weak acid as shown in the equation. The following titration curve was 10 milliliter sample of HASC was titrated using 0.0550 molar NaOH. So now first what we need to do, they are saying calculate the molar concentration of azopic acid. So we have to first find the molar concentration of azopic acid. For that we are given with the NaOH concentration. So first of all, we are going to find the moles of NaOH. Moles of NaOH is going to be, we have concentration 0.0550, and we have the volume of NaOH that has been used up till the equivalence point, that is going to be 16. Mole of NaOH is equal to concentration times volume, which is 0.016, and that comes out to be 8.80 times 10 to the power minus 4 mole of NaOH. And NaOH and HASC has 1:1, NaOH and HASC has 1:1. So if it is going to be 8.8 times 10 to the power minus 4, this is also going to be 8.8 times 10 to the power minus 4. So we have got the moles of HASC, and now we are going to find the concentration of HASC, and that is going to be mole 8.8 times 10 to the power minus 4, and then dividing with the volume is 10 milliliter, we have to convert it into liter, 0.01, and the answer that comes out to be 0.0880 molar HASC. So the next question is saying, from the titration curve determine the approximate pKa of azopic acid. So pKa is going to be like, first of all we need to find the half volume of NaOH, which is at half equivalence point. that is going to be 8, because up till equivalence point the volume of NH used is 16 ml. So half is 8, and it is going to be at this point. And if we want to find out the value of pKa, it is going to be at this place. That is going to be 4.1. So first we need to find the half volume of NaOH, which is 8. And at this point we are going to have like pKa value, which is going to be 4.1. Then they are saying what is the value of the ratio ASC is over HASC. So the formula is pH is equal to plus pKa plus log of salt over acid. So we have salt, which is ASC, minus pH value is going to be pH value they have given us, which is 4.7, so I'm going to put 4.7 here. And pKa value we have found from the titration curve, which is 4.1 plus log of concentration of salt. Salt here is ASC minus, and acid is going to be HASC. So if this value goes there, it would subtract and forms log of ASC minus over HASC, and it comes out to be 4.6, taking anti-log on both sides. So this would comes out to be ASC minus over HASC is equal to 10 to the power minus 4.6, and the answer that comes out to be is 0.6. For the next question, they are saying dihydroazobic acid can be produced by reacting azobic acid with triiodide ion, as represented by the following equation. The student runs 3 trials of the reaction with different initial reaction of HASC and I3 minus, producing the following data. The rate law for the reaction is rate is equal to K HASC I3 minus. Explain how the data in the table support the conclusion that the reaction is first order with respect to HASC. So if you compare the trial 1 and trial 3, you are going to see it is multiplied by 2. They remains to be constant, and this is also increasing by 2 times. So that represents if the concentration is twice is doubled, the rate also doubles. So how I'm going to write the explanation for this? So the next question, calculate the value of rate constant K for the reaction. We want to find out the value of rate constant. K is equal to, we can put rate at the top, and at bottom is going to be HASC over I3 minus. We can use any trial. Let's use trial 1. This trial, for this rate is 2.457 times 10 to the power minus 4. HASC is going to be 0.450 times 1.2, and rate unit is mole per second, and its unit is mole, its unit is also mole, and the answer comes out to be 4.55 times 10 to the power minus 4, and they will cancel, like this will cancel with this, and molar will go at the top and S would come at the bottom. It would become per mole per second. They are saying that triiodide ion is significantly more soluble in water than elemental iodine. Identify the intermolecular force present between I3 minus and water is not present between I2 and water, which could explain the difference in solubility. Lewis diagram for I2 and I3 minus are provided. So I3 minus, when it's dissolved in water, is going to develop ion dipole force of attraction. It is going to attract with hydrogen. It is having partial negative charge, it is having partial positive charge. So this positive and this negative would attract each other, and they would be developing ion dipole attraction that is going to be developed between I3 minus ions and water. Next question, they are saying white phosphorus is composed of P4 molecules with a tetrahedral structure as shown in the diagram on the left. Each phosphorus atom is bonded to 3 other phosphorus atoms by single bonds. So we have to complete the diagram by drawing the non-bonding electrons. So first of all, we know this thing that phosphorus is P1531. Phosphorus first shell has 2 electrons, second 8, and last one is going to have 5 electrons. So if it has 5 electrons, 1 electron is present here, 1 is here, 1 is here. So remaining 2 electrons are remaining, which are going to be present here as lone pairs. In the same way, they are going to be present as lone pair here, because here phosphorus is also bonded with 3 other phosphorus, and in the same way a lone pair is here, and in the same way a lone pair is present here. So we need to remove only this part. Yes. In the reaction of white phosphorus with oxygen to form P4O10 is thermodynamically favorable at 298 Kelvin. The reaction is represented by equation 1. They are saying the entropy of the reaction is negative. Use particle level reasoning why the entropy decreases as the reaction progresses. So we can see here that we have a gas state here, and it is changing into solid state. The particles in the gas state, they are going to be more further apart, so there is more disorderness in the gas particles, and when they are moving towards the solid particles, where the particles are in more organized form, so we can say that in gas particles they are more dispersed than solid. The entropy decrease as the reactants, which include gas state, is converting to solid state. So how I'm going to write it? So as gas particles, they are more dispersed than solid. The entropy decrease as the reactant contains gas particles which are converted to solid particles in the product. The next question is saying the enthalpy change of a reaction is also negative. A student claims that the favorability of the reaction is driven by enthalpy and not by entropy. Delta G is equal to delta H minus T delta S. As we know that this is going to be negative, which makes this entropy change is negative, which makes minus T delta S to be positive. And if it becomes positive, then as we know that for the favorability of the reaction delta G needs to be negative, then this becomes negative only in that condition when delta H is going to be negative as well. Because as we know, minus T delta is positive. For the reaction to be favorable, delta G needs to be negative. And if delta G now needs to be negative, this enthalpy change must need to be negative. So it acts as a basically driving factor. So we can say one thing here, that as delta G is negative for reaction to be favorable, so as delta S is negative, the reaction can only be favorable, if delta H is negative. So it is a driving factor. For the next question, P4O10 reacts exothermically with water to form phosphoric acid and is represented by this equation. A chemist use a calorimeter experiment to determine the enthalpy change of a reaction as represented by the following diagram. So we have this diagram. Now they are saying they have given us mass of water, initial temperature, final temperature, molar mass of P4O10 and specific heat of water. They are saying calculate the amount of heat Q released during the experiment in kilojoules. Assume that the specific heat of the solution is the same as the water. So Q is equal to mc delta T. M is the mass of water, which would be 100 grams. Specific heat capacity is 4.18 and the final temperature is 22.38 minus the initial temperature, that comes out to be 22. So it's going to be 160 joules, and when we convert it into kilojoules, it would become 0.160 kilojoules. Now, as we know, Q of reaction is equal to minus Q of surrounding. That makes it minus 0.160 kilojoules. And now in order to find the enthalpy of reaction, what we need to do, minus 0.160 divided by, we have the mass of P4O10 which is 0.1 and its molar mass is 283.9. So 0.1 divided by 283.9, it comes out to be minus 450 kilojoules per mole. So for the next question, the chemist weighed out 0.1 gram P4O10 of and 100 gram of water to perform a second trial. In the second trial, some of the solid P4O10 stuck to the weighing paper and was not transferred to the calorimeter. So in fact, what is happening? P4O10 mass is decreased. P4O10 mass decrease. Then they are saying what is going to happen. Given that P4O10 is a limiting reactant, would delta T for the second trial would be greater than, less than, or equal to the value in the first trial? So definitely it is going to be less than. Why it's less than? Because if less P4O10, then what happened? Then less thermal energy would be transferred to water because the quantity of P4O10 is less now. So less thermal energy is transferred to water, causing temperature increase to be less than than 0.1 gram of P4O10. So for the next question, P4 also reacts readily with Cl2 to form phosphorus trichloride, which in turn reacts with Cl2. And they are saying calculate the standard enthalpy of formation of PCl5 by equation 5. This is equation 5. So we have to calculate enthalpy of formation for PCl5, and for that purpose we need to choose that equation in which everything is present, like PCl5 is present and also PCl3 is also present, because we are giving with the enthalpy of formation of PCl3 and also PCl5 as well. So we need to choose that equation in which everything is present, which is equation 4. So first I'm going to write equation 4 here. PCl3 gas plus Cl2 gas, and they are forming PCl5 in gas state. And enthalpy of reaction, enthalpy of formation is minus 88. So I am going to apply Hess law. So if you see PCl3, 4 moles of PCl3 are forming, but for enthalpy of formation we have only 1 mole. So if 4 moles are there and we have 1 mole here, so in order to apply this one here, first I'm going to write elements here, P4 plus Cl2. So when I'm going to write for PCl3 here, as 1 mole is present here, but in its enthalpy that is for 4 moles. So if I'm going to write for 1 mole, then I have to multiply 1 by 4 with minus 1148. And for this part PCl5, I have to find the enthalpy of formation here. And now I'm going to apply Hess law, starting point, and then we have ending point there. This is ending point. And when I'm going to apply Hess law, this is starting point. So one root will be from this point and the second root is going to be from this point. This is root 1 and this is going to be root 2. And now root 1 will be 1 by 4 times minus 1148 minus 88 and is equal to enthalpy of formation. And the final answer that comes out to be is root 2 is enthalpy of formation. Yes, and final answer that comes out for enthalpy of formation is minus 375 kilojoules per mole. So for the next question, equation 4 for the reaction that occurs is shown. Equation 4, PCl3 gas plus Cl2 is forming PCl5. And they are saying we have to find out the value of Kp for the mixture and partial pressure is of 1 atm. We have this diagram here in which how many chlorine particles are there. They are 1, 2, 3, 4, 5, 6, and for PCl3 they are 1, 2 only, and for PCl5 they are 1, 2, 3, 4. So if I'm going to apply the formula of Kp, which is equal to partial pressure of PCl5 divided by partial pressure of PCl3 dot P partial pressure of Cl2. Now partial pressure of PCl5, how many PCl5 are there? Because partial pressure is of 1 atm, and for PCl5 we have 4 particles there, so I'm going to put 4 there. For partial pressure of PCl3 I have 2 particles, I'm going to put 2 here. And for partial pressure of PCl only the chlorine is there, so I have to put like here like this. Yes, so chlorine particles are 6 there, you can see they are 6. So when I'm going to put it here, the answer comes out to 0.33. Now they are saying, does the value of Kp increase, decrease, or remains the same? if the temperature is increased to 596. So forward reaction is exothermic as enthalpy change is negative. So when we are trying to increase the temperature, then what happens? The equilibrium will shift backwards, so more reactants will be there and value of Kp will decrease, because backward reaction is endothermic, equilibrium will shift towards backward side as there are more reactants now, and reactants are in the denominator, so the value of Kp would decrease. So I'm going to write that would decrease as increase in temperature shifts the equilibrium towards towards left hand side, so more reactant and Kp will decrease. बस यार. This question, a scientist is investigating the properties of a mixture of CH3OH and H2CO. The scientists generate the following diagram to represent the mixture. Identify the hybridization of valence orbital of carbon atom in H2CO molecule. So this is H2CO molecule, and we need to find out the hybridization around a carbon atom. So we can do like sp, and for double bond we are going to consider as single, so it is going to be sp2. So this is going to be sp2 hybridized. In the diagram provided, draw a single dashed line to represent a strong hydrogen bonding between CH3OH and H2CO between this one and this one. So if we want to show the hydrogen bonding between them, how we are going to show? This is going to have a partial negative charge because oxygen is more electronegative and hydrogen is less electronegative, so having partial positive charge. And it is going to show an attraction towards the lone pair which is present on oxygen, which is having partial negative charge. It is having partial positive charge. So attraction will come from partial positive charge towards this lone pair like this. Next question, the scientist plan to cool a gaseous mixture of CH3OH and H2CO to form a liquid mixture and finds data on two compounds. They are saying propose a temperature to which a mixture should be cooled such that CH3OH and H2CO will both be a liquid. So we are given with the melting point and we are given with the boiling point. Above the boiling point, let's say we are going to join it with the dashed line. So above the boiling point, it is going to be gas, and before the boiling point, it is going to be solid. So it is going to be liquid between the melting point and the boiling point. So the melting point which is present between both of them, that is going to be 181, and the boiling point is going to be 254. So in between both of them we have choose 181. Why is that? Because 181 is that temperature above which both of them will exist as liquid. And why we have chosen boiling point as 254? Because before than that both of the liquids will exist, both of the liquids will be existing in the liquid state. So after that, the scientists analyze the mixture after it is cooled and it determines that 8.59 gram of CH3OH is present. Calculate the amount of thermal energy in kilojoules that was removed to condense the 8.59 gram of CH3OH. So we have a formula which is going to be Q is equal to delta H times the number of moles. And delta H for us is given, CH3OH is enthalpy of vaporization, and they are saying the energy that was removed. So the remove is going to be exothermic, so we are going to have minus 37.6 because they are releasing energy. So when I'm going to put minus 37.6 here, and the number of moles we can find out, mass by molar mass. Molar mass is going to be 32.04 for methanol, which is CH3OH, and the answer comes out to be 0.2681, and times with 0.2681, and that comes out to be minus 10.1 kilojoules. So this question, complete Lewis diagrams and some physical properties for compound X and Y are given. Based on Vesper theory, predict the geometry around silicon atom in compound Y. So if we are going to predict the geometry, that is going to SP, SP2, and that is SP3. So it is going to be SP3 hybridization around silicon atom. A student claims that compound Y has a higher boiling point than that of compound X because compound Y has stronger London dispersion forces. So the only difference between them is silicon here and carbon there. Carbon is having C612 and silicon is having 1428. So first shell is having 2 electrons, second is having 4 electrons, and here first is having 2 electrons, second is having 8, and the last one is having 4 electrons. So if we see silicon, it has more shells. It has more shells, like it has 3 shells, and carbon has 2 shells. So it is going to have, like, it has more shells, so it is going to have more polarizable electron, and that's why it is going to have stronger van der Waals force of attraction. So how I'm going to describe it? So this is a correct explanation that we agree, because compound Y, which contains silicon, has a larger, more polarizable electron cloud, because silicon atom has more occupied electron shell than carbon atom, giving compound Y stronger London dispersion force and higher boiling point than compound X. They are saying an equimolar mixture of two compounds is heated. When the mixture reaches 82 degrees Celsius, which compound will have higher vapor pressure? So basically, vapor pressure that is inversely proportional to the strength of force. So if you have strength of force, so if you have weaker force of attraction, you are going to have more vapor pressure. So if we see both of them, like compound X, which contains carbon, has weaker intermolecular force of attraction, so it is going to have a higher vapor pressure as compared to compound Y. So how I'm going to write it? Let's write the answer for C. So this is a correct explanation that compound X, which is having the weaker intermolecular force of attraction because it has less polarizable electronic cloud as well. So that is why it is having the weaker intermolecular force of attraction, and that's why it is going to have the higher vapor pressure, because I have already told you that vapor pressure is inversely proportional to the strength of intermolecular force. So for the next question, D part, the mixture is heated to 198 degrees Celsius in a sealed, rigid 12.5 liter container at which both substance are gases and total pressure in the container is 2.3 atm. Calculate the number of moles of gas particles in a container. So number of moles is equal to PV by RT. Pressure is how much? That is 2.3 atm. and then volume is 12.5 liter, and R is going to be 0.08206, and temperature is 198 Kelvin. We have to convert it into uh, like 198 degrees Celsius, so we have to convert it into Kelvin. So 193 plus 198 plus 273, and the answer comes out to be 471 Kelvin. So that is 471 Kelvin, and the final moles comes out to be 0.744 moles. So for the next question, we have this galvanometer in which we have zinc electrode on one side and we have aluminium electrode on other side. And they are saying write the half reaction for the oxidation that occurs at anode. So anode is the one which is more negative. So this is going to be anode, which is more negative, and oxidation take place at this place. So for oxidation, we have to put the electrons on the right hand side. So this equation will be reversed, and it is going to form aluminium plus 3 in aqueous form plus 3 electrons. Write the balanced net ionic equation for the overall reaction that occurs in the galvanic cell. So we have two reaction. Reduction take place at cathode. So for reduction, gain of electron is written on the left hand side, and it is forming zinc solid. While for oxidation, which occurs at aluminium, electrons will be on the right hand side. So Al plus 3 in aqueous form plus 3 electrons. So I'm going to multiply this with 3. So this one would become 3 zinc plus 2 in aqueous form, because this is aqueous, plus 6 electrons, and that would be forming 3 zinc solid. And this one will be multiplied by 2 because the loss of electron would be the same as the gain of electron, so it would be multiplied by 2. So this one would become 2Al solid and would be forming 2 aluminium plus 3 in aqueous form plus 6 electrons. So we have to add this equation and this equation together, and 6 electron from this, from the right hand side, 6 electron from the left hand side will be cancelled, and the final net ionic equation comes out to be 3 zinc plus 2 aqueous form plus this 2Al in solid form, and would be forming 3 zinc solid plus 2Al plus 3 in aqueous form. So this is going to be final net ionic equation. I'm going to write the final net ionic equation here. 3 zinc plus 2 in aqueous form plus 2Al in solid form, and they are forming 3 zinc solid plus 2Al plus 3 in aqueous form. Initially, each electrode has a mass of 50 gram. The cell is allowed to run at a period of time and is then stopped. Which electrode mass changed the most? So zinc has a molar mass. Zinc has a molar mass of 55.38, and aluminium has a molar mass of 27. So we can see one thing. There are 3 zinc. Okay, like there are 3 moles of zinc, we can say, which are reacting with 2 moles of aluminium. So for 3 zinc molecule like moles, we can say like it is going to be multiplied by 3, so that comes out to be 196 grams, and this will be multiplied by 2, and that comes out to be 54 grams. So if they are asking which is going to have the greatest uh, electrode mass change, so we can say it is going to be zinc. And why it is zinc? Because zinc experience greater change in mass as the reaction proceeds. 3 moles of zinc are used for every 2 moles of aluminium. So therefore, for 196 gram of zinc, 54 gram of aluminium will be consumed. So how I'm going to write it in detail? So this is going to be the right explanation for them, that zinc experiences greater change in mass as the reaction proceeds. 3 moles of zinc are used for every 2 moles of aluminium. Thus, for every 196 gram of zinc that are produced, 54 gram of aluminium are consumed. Initially, each electrode has a mass of 50 gram. The cell is allowed to run for a period of time, and now we are going to do the question number D. The standard zinc aluminium cell has a value of E naught cell which is equal to 0.90 volts. The scientists need a galvanic cell that produces a greater voltage. The scientist has access to chemical system in the table. If the system uses zinc half cell, then he is saying what is the maximum voltage that could be generated if we use another option from the table. So zinc is negative here, okay, and we need to produce the maximum voltage. So this is going to be anode, and for cathode we need a value which is going to be most positive, and that is going to be plus 1.50. That is going to be cathode there. And if we are using the formula E cathode minus E anode, then E cathode is 1.50 minus 0.76, and the answer that comes out to be is 2.26 volts. The following question about the glycolate ion, which acts as a base in aqueous solution. A Lewis diagram for the ion is provided. On the Lewis diagram in part A, circle the atom that accepts proton when the glycolate ion reacts with water. So this is glycolate ion, and if we want to find out that which is going to accept the proton, so this is going to be the oxygen. Why? Because it has extra lone pair which can accept a proton and which can forms a bond with the proton. Because it has 3 lone pairs, it has having 2 lone pairs and 2 lone pairs here. Next question, when the glycolate ion reacts with water, it forms glycolic acid, and there's an equation given below. B part is saying calculate the value of Kb for the glycolate ion. So first of all, we have glycolate ion which is having the concentration of 2.5 initial concentration, and it is 0 and 0. And now they are saying OH ions, they are going to be 1.3. So that means 1.3 is going to be present there. 1.3 times 10 to the power minus 5, and as it has 1:1, so this is also going to be 1.3 times 10 to the power minus 5. And if we are going to find out how many C2H3O3 minus is present at the equilibrium, so if they are producing 1.3 times 10 to the power minus 5, then the change is also going to be 1.3 times 10 to the power minus 5. So at equilibrium, like, we need to put minus there because that is a reactant. So at equilibrium, the concentration of C2H3O3 minus is going to be 2.5 minus 1.3 times 10 to the power minus 5. So putting values in this equation, we are going to have Kb is equal to HC2H3O3, which is 1.3 times 10 to the power minus 5 at equilibrium, times with OH minus concentration, which is also 1.3 times 10 to the power minus 5, which is given in the question. And at bottom, the concentration of C2H3O3 minus is 2.5 minus 1.3 times 10 to the power minus 5. And Kb value comes out to be 6.8 times 10 to the power minus 11. This is Kb. Now for the next part they are saying calculate the value of Ka. We know we have a formula which is Kw is equal to Ka times Kb, and if we want to find out Kw divided by Kb, Kw value is 1 times 10 to the power minus 14 and Kb value is 6.8 times 10 to the power minus 11, and the answer that comes out to be is 1.5 times 10 to the power minus 4. In part C, a student claims that H3O positive is a catalyst for the reaction. Do you agree or disagree? So if we see that H3O positive is added here and is also regenerated in step 2, but in the final reaction there is no H3O positive, that gives us all evidence that it is going to be an acid. And how we are going to write the explanation for part C? H3O positive is consumed in first step. You can see it is consumed in first step and is also regenerated in second step and regenerated in second step. In second step, you can see it is regenerated. Here it is regenerated and is not present in the final equation. So this is a evidence. This is a evidence that H3O positive is a catalyst.